investigatory levels because of the legal issues. If you put in intervention levels, you have to intervene. But investigatory means you don't know, you have to go and inspect the road section and decide what to do. So it's Western world, it's a legal side is very, very strong. So if you miss one word, it will be highlighted in the codes, and professional engineers responsible for answering to this question. So we never use intervention levels. We call investigatory levels. But these levels also, because nobody knows about these numbers, how it works. But it has been there for 50 years now, from UK to all over the world. But nobody has done a connection between the crashes and the skid resistance, because all we are trying to do is cut down the crashes related to skid resistance. So the 0.55 means it's quite good number. It's a reasonable flow is there, right? But we don't know whether 55 or 57 or 58 is the right number. It's very decent number for the past experience, but we have to trial, and also the weather patterns change now, right? Weather patterns change, everything is changed, extreme climate conditions, things like that. So how that affect to these numbers? And our first research, what we propose is not one number for each category. It's a probability curve between two numbers, range, within this range. But that's also not interested by the road engineers. Road engineers want one number. So not range. So these discussions are going on at the moment. It's a hot topic everywhere, but nobody has given a proper answer. This is what we come up with, this data mining models. Data mining models give reasonable direction for us to think about, immediately go and inspect the site and take some decision whether you have to do the treatments or not based on the past experience. Past experience is, in our model we had about 160 rules came out with the 3 years data. So that's generate automatically those rules according to the historic data. Not only the crash and the skid resistance alone, geometry, surface type, everything is included in that rule set. So in that study, I think we have to continue. We stop with recently, we have software as well, but we have to what is called trial in the real world. It is being used by 2004 to 2006 data, because that's the only data set we have with the crash data. Because most of the crash data coming to us 2 years late. It's too late. So crash data coming from police, everybody knows. So some of the data is complete, some of the data are half complete. So the complete data sets, it takes 18 months at least to get into a database. So we always analyze old data. So these are some of the practical issues.
And Justin, could you go to the slide that you fit the model, the skid resistance against with the edge of the road, of the seal or something, I think?
That's the one you are talking, is it? No?
No, go a bit further. That you show.
Further down. All right. Profiles.
Yep.
Yeah.
And this one.
Yeah.
Just that. I think all road authorities want to produce this kind of the good relationships like this one, But I think probably Dr. Tunwin would have a questions about this graph.
Yes, thank you. I have a discussion with Dr. So he give again my chance. Department of Highways also have done some research about this. Luckily we have another bureau named Bureau of Road Research and Development. They do a lot of research for us. So we hire a consultant. We have a our own equipment. We use a fixed slip method. So we drag it and we drive at speed, I think around 60 kilometers per hour. And we collect data for about 11,000 kilometers all over Thailand. We tried to do the same thing, but we got the R square of 0.2. So the data is almost flat. So I'm surprised, and maybe you can show us some technique, explain to me some technique. How can you get such a nice curve?
It is not a technique, it is the fact. It's it is a fact. This is what actual results what we got. But this is not the actually 100% data, you know. Can you see the 50%, 30%, 15%, 5%, and 1%? So what we got it is we haven't explained. So step 1, identify the location seal edges in the network for spray seal, dense, open graded asphalt. Populated skid resistant data for each seal edge, right? So whatever you have data with the seal edge is 5, say for example, you develop a probabilistic curve, right? So that's the curve, you get it. So you have in the network various places, right? 5 years old, what's the skid resistant, right? So you develop this probability curve, then this probability curve, you get the 1% or 5% or 50% from this curve and develop a point like that. So seal age 2 years, that's the point. It's a 15 percentile from that graph. So then you get to 15 percentile in 2007, similar one. So this is 50%, 30%, 15%, 5%, and 1%. Did you understood now? Yeah.
Yes, but don't we need to look at the other parameters like the amount of traffic per day?
No, this is not about that. This is actually this request came from, we have a body called APA, Asphalt Association. The Asphalt Association is the one who provide asphalt to the industry, right? So we criticize them. You have to have a product which should cater skid resistant for 10 years minimum. Because our normal criteria is intervene in surfacing is cracks. Cracks is normally start from 8th year. So our policy is 8 to 10 years, between 8 and 10 in a various location you should receive. But now there's another intervention that is skid resistant. So then the industry says, no, we are giving a good product to you. Where the problem is, can you show us where the problem is? Whether they have not providing a sufficient product or correct product. Then we have to do this one and see whether generally is it performing at least 8 years, 7 years. So that's what, just to get the rough idea. Then we can say to them and say that no, your product is not performing. This is the only information we have, and according to this information your product is not providing sufficient skid resistance after 6th year. So then they have to go back to the design and see whether what sort of aggregate they are using, their PA value is right, their quarries are providing correct aggregates, that kind of stuff. Because at the moment they say, no, we are doing a right thing. Can you show me where it went wrong? So we have to prove that one. So actually the APA provide $40,000 for us to do the analysis. So first round we have done this one. But as you said, you have to categorize. In this paper, if you go and look at it, the final conclusion says you have to categorize and do it in a proper manner. But we have the data again. Each category ultimately end up with 10 points. 10 points you can produce a probability curve. It's not good. So you have to have a sufficient data to develop a probabilistic curve. Because there are so many categories, the aggregates size is different, the dense or open graded or no chip, all kind of things. When you divide into certain categories, ultimately end up with 5 or 6 data points, which you cannot develop probabilistic curves. So this is we proved the methodology.
Thank you. Department of Highway try to do the very similar thing.
Good.
We try to put the skip resistance as a function of the age and the amount of traffic. Without the amount of traffic, the R square or the correlation was worse. With the amount of traffic, better, but still not, the R square still less than 0.5. And we collect data for like, I cannot recall, but it's definitely like 30 or 50 sections that we have screened out throughout those sections that we were not sure what the ages of the seal, what the amount of traffic or whatsoever. So we just choose those sections where we were sure of the data. Still we get very good.
Same story.
Results, yeah.
In our database also we screen out. Ultimately, some of the data is there, but we don't know the background with that data, how old is. So we ultimately filtered everything and we found only few points we can reliable few points.
Yeah, so after the filter, how many sections
I can't remember now. Yeah, this has been done. Can you see? Some time back, this is data is 2007, and this research been done about maybe 3 years, 4 years.
Also, you went back to the same section and correct the data again?
No, we haven't done anything after that. Don't follow up. Because the other reason is the equipment change last 3 years. This data is history now. No point to use because this is only for demonstration. Now we are using screen. So this is a F60 value. This is nose meter.
Justin, let me ask you one question, Justin.
Yep.
I think this graph is quite important. One thing I noticed that I want to ask is the rate of the change of skid resistance on each line is depend on so many parameters, like the aggregate size, the mix design. So from your point of view, which parameter has the most influence on extending the life of the skid resistance?
No, we haven't gone that far. This is what data mining is important. At the same time, we have to populate a database. Without enough data, we cannot. This is a demonstration only. That's a very high level presentation. So if you go to the categories as he suggested, each category, each aggregate size, each size of the aggregate, which based on the aggregates, which query you are provided, what is the PFV values. We don't have PFV values recorded anywhere. We couldn't find it. So that's what we use this indirect method just to get the feeling.
So from your explanation, I think mostly depends on the material, right? Because traffic and edge we cannot control.
Yeah,
right?
materials in the sense actually the polishing value. But the latest research says polishing value is no relation. So this is the first thing we heard in the conference, but still we don't believe. If you look at it, the literature now, there are a couple of papers. They call polishing values doesn't give any answers. So there are certain things. That's what this field is very unknown, very difficult to handle it. The only thing is what our data mining, if you have a full network of data mining can capture all the parameters and develop a rule set for each and every category. Even if you have 10 points, you have a rule developed in that area that can be used to predict. So it doesn't matter where the data is, it's automatically generate the rules.
What about the alternatives, like comparing between sealing techniques and overlaying techniques?
Definitely. This is
Still.
really up to the payment engineers, payment seal designers. They have to come out with some better. So, but we have developed a policy about PFV values. But what happened was that we developed that policy about 2 years ago without great research knowledge. Only what we did was we developed what is called expert panel group within Australia. I was sharing that group. We asked the question from each and everyone. They said with their experience, this is the type of knowledge we have. Using that knowledge, we developed a table. But we put it to the public. The industry said, no, we can't deliver. So we don't have that sort of aggregates in here. So we have to import from about 500 kilometers away from the site. So the still argument is going on. So the policy is held up for 2 years now.
Okay, thank you, Dr. Bunchai, for your valuable questions. เดี๋ยวผมจะso in Thai again เมื่อเช้านี้ที่เรามองกันอย่างที่บอกนะครับสกิทเนี่ยมันเป็นค่าที่ได้จากการวัดแต่ว่าเมื่อเช้า Justin propose วิธีการวัดอยู่หลายวิธีนะครับพวกเราคงสงสัยว่าวิธีไหนมันยังไงในแต่ละวิธีค่ามันคงไม่เท่ากันเป๊ะหรอกครับมันคงเป็น3 4 5ซึ่งมันมีความต่างกันอยู่แล้วก็อยากจะให้เขาคุยเรื่องว่าเขาดีลกับความแตกต่างนี้ยังไงแบบที่บ้านเราซึ่งเป็นสเตจแรกๆในการทำสกิทรีเสิร์ชเนี่ยครับคงต้องถามก่อนว่าวิธีไหนน่าจะเหมาะสมกับบ้านเราอะไรเงี้ยมันคงเป็นคำถามรีเสิร์ชแรกๆที่เราควรจะรู้ไว้ก็จะถามจากประสบการณ์เขานะครับแล้วก็จะให้เขาจบด้วยเรื่องของเทคนิคใหม่นะครับที่ว่าใช้รถผมก็เพิ่งได้ยินนี่แหละไอ้เมื่อวานไปรับมาจากสนามบินก็คุยกันเรื่องนี้เดี๋ยวจะให้เขาขยายความตรงนี้นิดนึงเพราะว่าวิธีการส่วนใหญ่เนี่ยที่ดิสคัสกับดร.ธันวินก็คือว่าเราวัดโดยตรงแต่รถเนี่ยเขาบอกเป็น indirect method แต่ว่าข้อมูลออกมาเนี่ยใกล้เคียงกันไม่มีการกระจายข้อมูลอะไรเท่าไหร่เดี๋ยวผมจะให้เขาแชร์วิวเรื่องพวกนี้นะครับ Okay, Justin, we got the 10 minutes left. There would be go for the measuring method for the skid resistance. This morning you proposed a couple of the method, the way that how we can find the skid values or the skid resistance, and you end up with the new technique, the scrim, right?
It's not new technique.
But new, very new in Thailand, very new in Thailand.
All right.
And my question is, I think there are the difference between the skid value coming from the different method. You know, I would like to know that how you deal with the difference, you know, between the value from the different method, how you pick the best one, and how you deal with the scattering data, and I would like you to end up with the scrim method, which you told me yesterday. The philosophy of the scrim method is the indirect method.
That's right.
But
if you
but
see,
yeah, but can provide you the quite convincing data in comparison with the conventional method. That would be the direct method that we can measure the frictions directly from the measuring device. I would like to share the view that indirect and direct, you know, in terms of the engineering sense, direct would be better, but in terms of the reliabilities of the data, it seems indirect method can give you more convincing data. I would like to know all these points that I mentioned.
I think it's a good question because we have a various equipments. All kind of equipments are quite good, but it support for different purposes. As I said, you know, if you are going in a footpath, right? Can you bring all those equipments to measure skid resistance? You can't. So you have only pendulum, right? Pendulum, you can bring it here also. We can test it. What's the friction value, right? Here you can't bring it. Then the grip tester. Grip tester it's good for the airports, right? Runaways, and various places are there site specific. It's all right. And also I'll come with another one which is called Vericom. There's a new gadget we are testing. We have developed a test method also which